high concentration to a region of lower concentration. So moving from a region of higher to lower concentration. Why do they to lower concentration, and why do they do this? Okay, I'll just I mean the rest of the part was also fine, nothing wrong with that. Why do they move from a region of higher concentration to a lower concentration? Like if I spray a perfume at one end, why do the particles move from a region of higher concentration to a lower concentration? Let's say that's a room. Why do they do that? Because the particles are constantly and randomly moving around, so they'll spread out eventually. So it would happen in solids, it can only happen in liquids and gases because the particles are moving around. So always remember to write this, that due to random movement of particles, that's the reason why they do that. And it's not going to happen in solids. You can't have diffusion in solids because the particles can't move around. It will happen in liquids, and it will happen in gases. Where would the diffusion be fastest, solid, liquids, or gases?
In gases.
Okay, so in gases, the particles are moving much faster. So it's going to be, this would be faster, and in liquid, it's going to be slow. You add an ink drop in water, and it takes a very long time for it to spread around. But if you spray perfume on one side of the room, you can almost immediately smell the particles from the other side because the particles are moving very, very quickly. So what else? What are the factors on which diffusion depends on? The speed of diffusion.
Temperature.
So one of them is temperature. So higher temperature, why does higher temperature lead to faster diffusion?
High kinetic energy.
Energetic particles.
Okay, so you have more kinetic energy, more energetic particles, and they travel faster. What's the second important factor?
Concentration gradient.
Obviously, they move from a region of higher concentration to lower concentration, so there has to be a difference. But what is the second factor on which the speed of diffusion depends on?
Particle size.
Okay, that's instead you should call it mass of particles. It's how heavy the particles are. So lighter particles, they travel faster. So for example, so both factors, these both factors are the more important factors that determine how quickly diffusion will happen. And so, I mean, the real world examples are that you can, if there's hot food, you can smell it. But if there's cold food, you can't really smell it because the particles are not really traveling that fast. They don't even reach your nose or your taste buds. And so, which is why you like to eat hot food. You don't like to eat cold food because the particles would not be moving around and they wouldn't be able to reach your taste buds, or you can't even smell it properly. And the second is the mass of particles. The mass of particles can be determined by looking at the atomic masses in the periodic table. So atomic or molecular masses. So if I have a molecule of, let's say, CO2, how would I figure out the mass of this particle? I would open a pure table. So let's say, let's open the EQA pure table PDF. So I've got this pure table in front of me, which is, and remember in the pure table, the bigger number is the atomic mass. Just a second. So you've got carbon dioxide. It's got carbon, which is 12, and oxygen, which is 16. The bigger number, the position could be different of this bigger number, but the bigger number out of the two numbers, that's the atomic mass. So this 12 could be written downwards. It could be written on the side or on the right side. But just remember, the bigger number is the atomic mass. Wherever that is around the element, that doesn't really matter. The key would be given over here every time. So carbon is 12, oxygen is 16. So how do you find or what is the molecular mass of this molecule? This is 12, this is 16, and there are 2 oxygens. So that's going to be 16 times 2. So what do you get for this? For this
44. 44.
That is 44. If you talk about hydrogen molecule, that is going to be, look at hydrogen in the periodic table, that's going to be at the top, that's just 1, that's the atomic mass. And the hydrogen molecule has 2 hydrogen atoms, so that's 1 plus 1, that's going to be 2. If I talk about, let's say, some other molecule, HCN. So what is HCN? What is the mass of HCN? Nitrogen over here is 14, C is 12, and H is 1. So HCN would be 1 plus 12 plus 14. What is that? 12 plus 14 is what? 27?
26.
1. Hydrogen is 1. Anyway, so which one out of the 3 will have the fastest diffusion? And which one is going to have the slowest?
Hydrogen will be the fastest.
Okay, so this one is the fastest, and this one over here is the slowest, because that's the heaviest. So remember, 2 factors: one is temperature, the other one is the size of the particles. Now, so you'll get typical questions on this one. They'll ask you about diffusion. Diffusion is moving from higher concentration to lower concentration due to random movement of particles. And the other one is about, one question would be about molecular masses. And there are going to be some typical questions about molecular masses, which would be, I mean, these are some other examples of questions, which I'm just going to do. So they have one very favorite question that pretty much always comes, and that's they usually have a tube-like structure. On one end of the tube, they've got a cotton wool, and that wool is soaked in HCl. Hydrochloric acid, they've got another cotton wool on the other side, and that's soaked in ammonia, which is NH3. And they ask you that the HCl and NH3 react. When they meet, they're going to react. And they react to form a white solid, which is NH4Cl. Forget where the formulas are coming from, but a white solid is going to be formed. And the question is, where exactly will the white solid form? So you've got particles that are traveling from one end, and you've got particles that are traveling from the other end. So where do you think would they meet? Will they meet right in the middle? Let's call that A. Or will they meet somewhere over here, or will they meet somewhere over here? So open a periodic table and calculate, or try and calculate, where would the particles meet? Who's traveling faster? Who's traveling slower? There's a periodic table nikalo now, or I mean, just Google it's. In a window, you can just use the AQA periodic table. There's plenty of periodic tables out there, but just write AQA and periodic table, a PDF would open up. इसका quickly कोई बता दे कि molecular mass of HCl, molecular mass of NH3.
So the molecular mass for HCl is 36.5. And then for NH3, it's 17.
Yeah, so one of them is 36.5. This one, right? And this other one is 17. So who's going to travel faster?
Ammonia.
Because that one is faster, and
Sir, तो C भी बनेगा.
so because ammonia is going to travel faster, so that's why it's going to travel quickly. And they're going to meet at C. C is the place where they're going to meet because this gas would travel much faster and this would be much slower. So they'll probably end up somewhere over here. Is this clear? This is one very typical question that they usually ask. Is this clear?
Sir.
Yes, sir.
Yes. And then there's another one which is about a porous spot. So there's a very typical porous spot question where they're going to ask you. So a porous spot question, which is similar to this, if I'm able to draw this, there's going to be a porous spot and it's going to have, let's say it's got tubes coming out of it. And so let's say, 1 second, this away. So let's say we have a liquid in the porous spot at the bottom of this tube. And remember, it's a porous spot. That means gases can move out and they can also come inside it. And on top of the porous spot, they put a gas jar that has hydrogen in it. So there's hydrogen gas outside and there's CO2 gas that's inside. And remember, we've already calculated the MR of CO2. That's 44 molecular mass of which is 44. Hydrogen is 2. So the question is, what happens to the water level at X? There's some water over here. So what's going to happen to it? Can anyone answer this? And this opening is open. It's not closed. I mean, this red one is just one container with a tube that's connected to it, and the tube has water over here. So what will happen to the water level at X? Anyone? Will it increase? Will it decrease? Will it stay the same? Okay, so it's going to increase, and why would it increase?
Because carbon dioxide has more molecular mass than water.
Ignore water. Forget water. I'll explain why it would increase. So basically, the porous spot inside has carbon dioxide. Okay, let me explain this. It has carbon dioxide, and outside the porous spot, you've got hydrogen gas. Let's say these green particles are all. They're all hydrogen gas, right? So where will hydrogen gas diffuse? Remember, what is diffusion? Diffusion is when particles move from a region of higher concentration to a region of lower concentration. So hydrogen gas will try to move inside the porous spot, right? Is that clear?
Yes, sir.
Okay, so it will try to move inside the porous spot. So the hydrogen gas will start moving inside the porous spot. And inside the porous spot, you'll have more and more hydrogen gas. And what will happen to carbon dioxide gas? The carbon dioxide gas has a higher concentration inside the porous spot. It has no concentration outside the porous spot. So it will try to move outside the porous spot, right? Is that clear? Okay, hydrogen will try to diffuse inside the porous spot. Carbon dioxide will try to leave the porous spot. Is that clear?
Yes, sir.
Who's going to travel faster? Hydrogen or carbon dioxide?
Hydrogen.
Hydrogen.
So the result is that hydrogen gas is going to diffuse inside the porous spot at a much faster speed. So what will happen inside the porous spot? There's going to be more and more. What will happen inside the porous spot? There's going to be more and more hydrogen gas that will come inside, right? At a much faster rate. And that hydrogen gas will also move inside the tube over here. And it will start pushing the water, and which is why the water level at X will start to increase. Idea clear? Okay, basically it's you had carbon dioxide and you had hydrogen gas that was outside. Carbon dioxide was trying to leave the porous spot. It was moving from a region of higher concentration to a region of lower concentration. And hydrogen gas, on the other hand, was moving from a region of higher concentration to a region of a lower concentration, right? But hydrogen was traveling faster, which is why it started entering the porous spot at a much faster speed. Porous spot ka matlab hai gases can actually move in and out, right? And since hydrogen was moving in, a lot of hydrogen gas was moving in, and which is why there was more and more gas inside the porous spot, which started pushing on the liquid over here, and the level at X started to increase. Ye clear hai saro ko? Right?
Yes, sir.
So, and you'll be asked to write an explanation for this. So the explanation would be that initially H2 gas moves or diffuses into the porous spot. You can remember to use the correct scientific terminology. To move, instead of moves, diffuses. So it diffuses into the porous spot at a much faster rate. So it one second. Anyway, so initially H2 gas diffuses into the porous spot at a much faster rate. Then CO2, which tries to leave the container. And more gas inside the porous spot pushes the water. So it pushes the liquid. Which rises. Achha, next one. What will happen after that, after some time? Will the water level at X continue to move upwards, or will it come down? We'll start with, yes, it will?
It'll return back to X.
And why would it return back?
Because the particles are in equilibrium with one another.
No, but the reason is because CO2 is trying to move out, right? But it's just taking longer time. So why did the amount of particles inside the porous spot increase? Because initially all the H2 gas started entering the porous spot. But remember, CO2 is leaving, but it's leaving at a much slower rate. Eventually, let's say after 1 hour, it leaves. So the number of gas particles would become, will come back to the original amount, because the CO2 molecules will slowly leave the container, but they're just taking longer to leave. So it's like a room where people are entering into the room at a much faster rate than they're leaving the room. But eventually the ones that are inside would eventually leave, but they'll just take longer time. So after some time, the CO2 diffuses out. So it diffuses out, and what happens? It diffuses out. So water level at X comes back down. Comes to the original level. But anyway, so that's pretty much it. Diffusion, you get very typical questions. So we'll start doing some questions on diffusion. And let me open the worksheet for this. TK will try and do some past paper questions on this. So just a second. Anyways. Yeah, most of the questions are going to be very straightforward and very simple. So let's start. with these, and hold on a second. So starting with the first one, which statement do you think is incorrect? Is correct, sorry. So you've got a couple of you've got these changes of state. Although the change is not shown on the diagram, a gas can change directly to a solid. Is that true?
Yes.
Yes, sir.
Okay, that is true. The other ones are, why is B wrong? What's incorrect about B? 1 and 3 involve particles moving closer together.
Because in change 1, the particles move further apart.
Okay, so in change 1, the particles solid to liquid, they're moving further apart. What's wrong with C? Two and 4, are they moving further apart? Yes.
4, they're moving closer
Yes,
together.
sir. Liquid and solid together are.
Okay, they're moving closer together. What about 3, 4, and 5 all involve the release of energy. So which one does not involve release of energy?
Change 5.
Change 5, because solid
Right, sir.
that needs to gain energy. And anyways, this one, Evo question, this is the same question. So this was about HCl, right? This is ammonia. So this was 17, right? This was 36.5.
D answer.
Okay, so the answer is D. Instead of meeting in the middle, this is going to be faster. It will travel faster. So it's going to cover a longer distance. So it's going to reach D. They're going to meet at D. One of them is faster. So what about this one now? Try solving this one. This is a similar question, but this time, one of them is HCl, which we know is 36.5. And the other one is ethylamine, which is C2H5NH2. So it's this one. Can you figure out the molecular mass of this? And after that, can you figure out where would they meet? C2H5NH2. NH2, I think. This is NH2.
So the mass would be 45.
45. So where will they meet?
So they're at 8.
Okay, so one of them is traveling faster, and I think it's this one that's faster, right? So they're going to meet at A. Next one is when drops of bromine are placed on a tabletop at one side of a room, the smell of bromine can eventually be detected at the other side of the room. What is not part of the explanation of this? So first one, after evaporation, the bromine particles, not part of the explanation. So bromine, that's diffusion happening. What is not part of the explanation?
D.
D, sir.
So D, that's because that's a solid. It's then they're talking about diffusion that happens in liquids and gases. What process provides the best evidence of the particle theory of matter? So we talked about diffusion. So I guess that's easy. So out of these ones, he's saying that they're identical balloons and they are filled with different gases. The gases gradually diffuse out. Which pair of balloons will deflate at the same rate? So he's saying that the gases are diffusing out of the rubber. So which one will diffuse at the same rate? It's going to be periodic table and figure out what.
So R and S.
R and
S, because they're both 28.
Okay, so R is 28 and S is also. So S is also 28. And so both of them are 28. Just a second. So both of them are 28. Next one, which statement explains why the gases propane and carbon dioxide diffuse at the same rate? Why do they diffuse at the same rate?
Sir, D.
Sir, D. They have the same relative.
Okay, they have the same. They have the same molecular mass. I mean, you can just calculate it. They're exactly the same, 44 and 44. A drop of liquid bromine is placed in the bottom of a gas jar. Brown fumes of bromine vapor slowly spread through the covered gas jar. Why does this happen?
Sir, B.
Okay, remember, he's talking about diffusion. Why does diffusion happen? Because they're always randomly moving around. Okay, so if you place certain particles at one corner, the particles would just randomly move around and they'll spread out. That's why they move from a region of lower concentration to region, higher concentration to region of, because they're just randomly moving around. You have a question, Agya. We've got, he's saying which gas when present in the beaker over the porous spot. Remember, there's oxygen gas that is inside the porous spot. Oxygen is 32. Okay, that's 16 plus 16, that's 32. So which gas would be present outside the porous spot, like in this area over here, will cause the water level at Y to rise? So is it going to be a lighter gas or is it going to be a heavier gas compared to oxygen?
Gas.
Okay, so remember, it's the gas that is going to be outside, whatever that gas is, let's call it X. It's got to be a lighter gas so that it travels inside the porous spot at a much faster speed compared to oxygen leaving the porous spot. Okay, so the gas must be a lighter gas. Only then, okay, so this is going to be a lighter gas. Only then will there be extra gas inside the porous spot, and that will push the level of the water on one side so that it becomes higher on the other side. So which one is it?
Methane.
And methane is 12 plus 1 plus 1, that's 16, right? So that's the lighter gas. You clear the question, Saruk?
Yes, sir.
Now, this is a question about boiling points. You're saying that there is boiling points are given. The air is cooled. The first substance to condense is water. If the temperature is lowered further, which is the next substance to condense?
Carbon dioxide.
Yep, it's going to be carbon dioxide because its boiling point or condensation point would reach first. So it's going to be carbon dioxide. So how would you describe a very dilute sugar solution? A very dilute sugar solution.
B.
Okay, so a very dilute sugar solution means that you've got lots of water molecules, right? Lots of them. And you've got very few sugar molecules. So let's say the red ones are sugar molecules. So the sugar molecules are going to be widely separated because there are very few of them. And the water molecules would all be close together. So widely separated and close together. And all of them would be moving around because in liquid state, they're all moving around. Or so next one. Pista clear? The last one.
Yes, sir.
As the conical flask contains compound X, which is present in solid, liquid, and gaseous states. Which statement is correct? Well, if I have water in gaseous state, water in liquid state, water in solid state, do they have different masses or do they have exactly the same masses?
Exactly the same.
Okay, because it's H2O, it's still H2O. So the first statement is wrong because changing the state will not actually change the mass. It's going to be the exactly same particle. Energy is released when X changes from liquid to solid. Is that true? This one.
Yeah, that's correct.
Okay, liquid to solid, that one is correct. EBS on, and neon diffusing faster than carbon dioxide because it obviously has a lower mass. You can go and check that. Which one is a gas? Which one is a gas? And which one do you think is a liquid as well? Which one is a gas? Okay, gas
Sir,
one.
A.
A is a gas, and which one is a liquid then? I mean, although that's not part of the question, but which one is a liquid? If they had asked you about that.
C.
I think it's going to be C because it's loosely packed, right? So this is kind of pretty much the same. How would you know that a liquid is pure? How would you know that?
Sir, D.
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 D. I told you we wrote this down as well, that the boiling point and the melting point, that's how you figure out whether something is pure or not. So then the next one, which elements would be gaseous at minus 190? And remember, make sure negative values, you get confused with negative values. So melting point, boiling point. And he's talking about, so the temperature has to be greater than the boiling point, minus 190. When is it a gas? It's a gas where the temperature is higher than the boiling point. So is minus 190 higher than minus 186?
Sir, it's lower.
It's lower, right? So the first one is not going to be a gas. Is minus 190 higher than minus 269?
Yes, sir.
Okay, that's a gas. It's higher than this as well. Is minus 190 higher than minus 196? Right.
Yes, sir.
Yes.
And it's not going to be higher than this, right? So remember, a substance is going to be a gas. This is the melting point. It's going to be a gas if the temperature is higher than its boiling point. So these three, helium, neon, and nitrogen. So it's going to be C. Piston balloon wala, this is kind of the same. This one is also another, you get questions like these as well. So he's saying something is decomposing. I mean, this substance over here, like over here at the bottom, it decomposed, right? So it turned into NH3 and HCl. And we know the masses. This is 17, this is 36.5. Who's going to reach the litmus paper first? I mean, the gases would be produced at the bottom. Who's going?
Ammonia.
Ammonia is going to travel faster, right? Do you know what ammonia does to a litmus paper? I mean, it's a base. Do you know what happens? I mean, I'll just add this information that ammonia is a base. This one is an acid. So what does a base do to a litmus paper? It turns it
blue.
It turns it blue. And what does an acid do to a litmus paper? It turns it red.
Red.
So it's going to turn blue first, and then it's going to turn red, because HCl will also reach here, but it will take longer for it to reach there. So I mean, this information, if you don't know this information, we'll probably do that much later on. So this one is interesting. So a liquid X contains, let's do this one, is going to be our last question for now. A test tube containing a liquid X is placed in a beaker of boiling water. The liquid X starts to boil immediately. What is the boiling point of liquid X? So there's boiling water, right? What is the temperature of boiling water?
100 degrees Celsius.
So that's 100 degrees centigrade. So he puts a test tube that contains a certain liquid, right? X, let's call that X. He says that it starts to boil immediately. So is its boiling point higher than 100 or lower than 100?
Sir, lower.
Lower than 100, right? Sure, okay. And so first two are wrong. So the only option is going to be
C.
But is it C or D?
C, sir.
Why not D? Because D is also lower than 100. Between room
Sir,
temperature.
like a liquid immediately.
So if a liquid is at immediately they go room temperature, let's say this is at room temperature, this is also room temperature. So immediately it will start boiling immediately. Okay, let's say its boiling point is 20 degrees centigrade. And you're putting it in 100 degrees centigrade, it will boil immediately, right? What temperature to common, I don't know, but why C, why not D? Focus on this. It's a liquid. So if it's a liquid, what does that mean? Is it boiling point higher than room temperature or lower than room temperature?
Sir,
higher
higher.
than room temperature.
So it's higher than room temperature. Okay, if it's lower than room temperature, it would start boiling at room temperature, right? So basically, it's going to be D. Well, one thing that we figured out was that it's going to be lower than 100, right? And by looking that, since it was a liquid, the only reason it's a liquid is that its boiling point must be higher than room temperature. That's why it's a liquid. It's not pani hota na, water that's a liquid at room temperature. Why is it a liquid? Because its boiling point is much higher than room temperature, right? So the boiling point would probably be somewhere in between. It would be higher than room temperature because it's a liquid. But since it boils immediately, that means it's lower than 100. So it would be between room temperature and 100. Your question clear? समझ आया? Adil, is this clear?
Yeah, yes, sir.
Yes, sir.
चलो ठीक है. थोड़े से इसका क्वेश्चन एक दो और कर लेंगे नेक्स्ट क्लास में. I'll give you a certain assignment as well, and we'll move on from there. ठीक है. Separation technique, experimental वगैरह, we'll try and cover that. चलो ठीक है, कल फिर हम कंटिन्यू करते हैं. ठीक है.
ठीक है, sir.
Okay.
Allah Hafiz.
Professor.